What does reconstituted granite mean?
Okay, I'll take the first part, then Joe can take it. When you have any rock exposed to air and water and CO2, it will actually begin to disintegrate. Depending on what's in it, the disintegration can be really quick or it can be really slow. In the case of granite, where you have any sort of regular water, CO2 from the air, or acids from the plant roots, it will break apart easily, largely due to the fact that it's got feldspar as a major component. And we know one thing: feldspar plus carbon dioxide plus water reacts really quickly to form clay. Clay has no great strength at all, and the rock begins to fall apart. So if you walk over any granitic mountain in a desert or in the jungle, you will usually notice the surface is crumbly, and it's the feldspar in it that's falling apart, and that will produce sand from it. The sand washes down. Like here in Queensland, we have famous mineral sands, and the reason is the granitic rocks up on New England tableland have been rained on. All the sand has washed down the rivers, gradually separated out, and the mineral bits, the titanium and a few other containing rocks, are the only ones that have survived and been washed by our coastal currents up to where they've been trapped behind big igneous deposits or big igneous flows, and that's what's formed our big sand islands and sand deposits off the coast. So igneous rocks break down fairly rapidly. Joe, what's your take on it?
Yeah, just a quick comment then perhaps on some of the sandstone, because you'll often find in geology books or textbooks or local guidebooks, they talk a lot when you find a sandstone formation, like effectively what Uluru is. It's a sandstone, it's a conglomerate. When you're dealing with things like this, they'll often talk about how this formed. Often the red sandstones, the red coming predominantly from iron, which is usually the glue which is gluing it back together. They'll often talk about how it formed in a desert. What it almost never gets asked is, where did all this sediment come from in the first place? Because as a sort of very generic rule, for 1 cubic meter of sandstone, you need around 3 cubic meters of original rock in order to be eroded down into sand to then actually produce the rock, right? The sandstone. And what's almost never asked is, where did this rock come from in the first place? Well, it's originally a granite, right? That's not exactly a soft rock, so it's going to take an enormous amount of erosion to actually break that down into sand in the first place, to then reconstitute it into a sandstone, a reconstituted granite by the end of it. And you remember, Ayers Rock is just the tip of the iceberg, in the sense that there's 6,000 meters worth of this arkose underneath it. So it's worth thinking, when you see a sandstone deposit like this, where did that sand come from? Because that also requires a huge volume of water to break it down in the first place. And that's something that's generally ignored by secular geologists.
Just to go one step further, the reason we call it a reconstituted granite is the materials in it are still the same ones that you can see in the Peterman Ranges, and that over there they're in hard granite, which is cohesive. Down here in Uluru, you'll find that the separate bits are now separate, but slowly or tightly glued together by a very weak cement of the iron. And so it's recognizably a granite, but the rocks are sediments rather than igneous. So that's why we use the word reconstituted granite. Granite's just an old word meaning grainy thing. And you can see the grains still there in Uluru.